Time travel, the concept of traversing through time, has long captivated the human imagination. From ancient myths to modern science fiction, the idea of moving through different eras has been a source of endless fascination and wonder. It's a concept that transcends cultures and epochs, appearing in the folklore of ancient civilizations as well as in the cutting-edge theories of contemporary physicists. It has been a staple of science fiction literature and film, igniting our dreams of witnessing historical events firsthand or catching a glimpse of the future. From H.G. Wells' The Time Machine to blockbuster movies like Back to the Future, these stories have fueled our imagination and inspired countless discussions about the nature of time and our place within it. But is time travel merely a product of our imagination, or could it be a scientific possibility? This question has intrigued not only storytellers but also scientists who seek to understand the very fabric of our universe. Theoretical physicists have proposed various models and hypotheses, from wormholes to the bending of space-time, that suggest time travel might not be entirely out of reach. Theoretical physicists have grappled with this question, exploring the nature of time and the potential for its manipulation. Einstein's theory of relativity, for instance, revolutionized our understanding of time as a dimension intertwined with space, opening up new possibilities for how we might traverse it. Quantum mechanics, with its strange and counterintuitive principles, has further complicated and enriched our understanding of time. The allure of time travel lies in its ability to challenge our understanding of reality. It invites us to ponder profound questions about existence, causality, and the nature of the universe. What would it mean to change the past? Could we alter the course of history, or are we bound by the immutable laws of cause and effect? These questions push the boundaries of our knowledge and force us to confront the limits of what we can comprehend. It forces us to confront the limits of our knowledge and consider the profound implications of altering the past or glimpsing the future. The concept of time travel also raises ethical and philosophical dilemmas. If we could travel through time, what responsibilities would we have? How would our actions in the past or future affect the present? These are not just theoretical questions, but ones that touch on the very essence of human morality and decision-making. The very notion of time travel is intertwined with fundamental questions about causality, free will, and the nature of time itself. It challenges us to think about the universe in new and unconventional ways. Are we masters of our destiny, or are we merely players in a predetermined cosmic script? The exploration of these ideas has led to some of the most intriguing and mind-bending theories in modern science. While time travel remains a theoretical concept, its exploration has led to fascinating thought experiments and the development of intriguing theories. Scientists and philosophers alike have used the idea of time travel to explore the nature of reality, the limits of human knowledge, and the possibilities of what might lie beyond our current understanding. These explorations have not only deepened our understanding of time, but have also inspired new ways of thinking about the universe. These explorations not only deepen our understanding of time, but also shed light on the fundamental laws that govern our universe. By studying the possibilities of time travel, we gain insights into the nature of space-time, the behavior of particles at the quantum level, and the intricate dance of forces that shape our reality. This knowledge has the potential to revolutionize not just our understanding of time, but of the universe itself. The journey through the realm of time travel is a testament to the boundless capacity of the human mind to question, imagine, and explore the unknown. It is a journey that continues to inspire and challenge us, pushing the limits of what we know and inviting us to dream of what might be possible. As we venture further into the mysteries of time, we are reminded of the infinite potential of human curiosity and the endless possibilities that lie ahead. One of the most perplexing challenges in the realm of time travel is the grandfather paradox. This paradox is not just a simple puzzle, but a profound conundrum that has intrigued scientists, philosophers, and writers for decades. It delves deep into the very fabric of our understanding of time and causality. This thought experiment presents a scenario where a time traveler ventures into the past and eliminates their own grandfather before the conception of their parent. The implications of this act are staggering, as it sets off a chain reaction that questions the very nature of existence and reality. This seemingly simple act creates a profound causal contradiction. The moment the grandfather is removed from the timeline, a cascade of events is set into motion, each more perplexing than the last. If the grandfather is removed from the timeline, the time traveler's parent would never be born, and consequently, the time traveler themselves would cease to exist. This leads to a paradox where the cause and effect loop back on themselves in a way that defies logic. But if the time traveler never existed, how could they have traveled back in time to commit the act that led to their own non-existence? This question is at the heart of the grandfather paradox and highlights the potential for causal loops that seem to have no beginning or end. This paradox highlights the potential for causal loops and the perplexing nature of time travel. It suggests that our linear perception of time may be an oversimplification of a far more complex reality. The grandfather paradox raises fundamental questions about the consistency of timelines and the possibility of altering the past. It forces us to consider whether time is a fixed, unchangeable sequence of events, or a malleable construct that can be reshaped by our actions. Does the act of changing the past create a new, branching timeline, or does it unravel the fabric of reality as we know it? This question is central to many theories of time travel, and has been explored in countless works of science fiction. These questions have fueled countless debates among physicists and philosophers alike. Some argue that any change to the past would create a divergent timeline, while others believe it would cause a catastrophic collapse of the space-time continuum. The grandfather paradox serves as a stark reminder of the potential complexities and contradictions that arise when we contemplate the possibility of time travel. It challenges us to think beyond our conventional understanding of time and consider the broader implications of our actions across different temporal dimensions. It challenges our intuitive understanding of cause and effect, suggesting that the past may not be as immutable as we perceive it to be. The grandfather paradox remains one of the most thought-provoking and enduring puzzles in the study of time travel, inviting us to explore the mysteries of time and existence. The bootstrap paradox presents another intriguing challenge to our understanding of causality in the context of time travel. This paradox is a fascinating concept that has puzzled scientists, philosophers, and science fiction writers alike. It delves into the complexities of cause and effect, questioning the very nature of how events unfold in a timeline. This paradox involves a closed loop of cause and effect, where the origin of an object or piece of information is lost in the cyclical nature of time. It creates a scenario where the past and future are intertwined in a way that defies our conventional understanding of linear time. In this loop, an object, piece of information, or even a person is sent back in time, becoming their own origin. This creates a self-sustaining cycle where the item or information has no clear point of creation, existing perpetually within the loop. Imagine, for instance, a time traveler who gives a copy of Shakespeare's Hamlet to a young William Shakespeare. This act sets off a chain of events that blurs the lines between original creation and replication. Shakespeare, inspired by the work, copies it verbatim and publishes it as his own. The play, now attributed to Shakespeare, becomes a cornerstone of English literature, studied and revered for centuries. The play goes on to become a literary masterpiece, celebrated through the ages. Its influence permeates various aspects of culture, education, and the arts, solidifying its place in history. The question then arises, who truly authored Hamlet? Was it Shakespeare, the young playwright who published the work, or the time traveler who brought the manuscript from the future? The time traveler brought a copy from the future, but that copy originated from Shakespeare himself. This creates a paradox where the play exists without a clear point of origin, looping through time. This paradox challenges our linear perception of time, suggesting the possibility of events existing without a clear origin point. It forces us to reconsider the nature of time and causality, opening up new avenues of thought and exploration. The information or object in the loop seems to exist outside the conventional flow of time, perpetually cycling through history. This cyclical nature raises questions about the stability and consistency of the timeline. The bootstrap paradox raises profound questions about the nature of originality, creation, and the very fabric of reality. It challenges us to think beyond the linear progression of time and consider the possibility of a more complex, interconnected temporal framework. It suggests that the past, present, and future may be more interconnected than we can fathom, with information flowing not just forward in time, but also backward, creating a tapestry of interconnected events. This interconnectedness hints at a universe where time is not a straight line, but a complex web of interwoven moments, each influencing the other in ways we are only beginning to understand. The predestination paradox explores the possibility that the past is fixed and unchangeable, despite any attempts to alter it. This paradox suggests that even if time travel were possible, our actions in the past would be predetermined, leading to a preordained outcome. Imagine a time traveler who ventures into the past to prevent a tragic accident. However, their actions, perhaps unknowingly, set in motion a chain of events that directly lead to the very accident they were trying to prevent. In this scenario, the time traveler's attempt to change the past becomes the cause of the event they sought to avert. The predestination paradox implies that free will in the context of time travel may be an illusion. Every action, even those taken with the intent to change the past, could be seen as an inevitable step towards a predetermined outcome. This paradox challenges our understanding of free will and the nature of choice. It raises the question of whether our actions truly shape the future, or if we are merely playing out a pre-written script in the grand theater of time.